Hey all, welcome to your virtual classroom journey of Amazon Web Services Certified Solution Architect level. We are going to learn in this whole course about how do you achieve AWS Certified Solution Architect Associate level. But do you know what is AWS? And before you go to the AWS, do you know what is cloud computing? It makes very important for you to understand what is cloud computing, and then it's good to go to the Amazon Web Services. So let's start with the overview of the cloud computing. What is cloud computing? Have you ever thought about what are the different models of the cloud computing? Have you ever tried to understand? Because when you go and ask people, people would say, oh, move to the cloud. But do they really understand what is cloud computing? And why is it so important now that people are everybody, the buzzword in the industry has started is a cloud computing. And that's why let's get to the cloud more deeper. Let's try to define the cloud computing. Before we move on, I would like to quote a few famous quotes by some of the who's and who's of the industry. And my favorite, Mr. Steve Jobs, has to say about this that in 1997 he made this statement, I don't need a hard disk in my computer if I can get to the server faster. Carrying around these non-connected computers is Byzantine by comparison. And he's very right. He made this statement in years back, but that's his vision. He is a visionary, we all know. And he knows that cloud computing is the go-to solution for most of the problems in the industry. And that's why Scott McLeay, former CEO of Sun Microsystem, has to say, we believe we are moving out of the ice age, the iron age, the industrial age, the information age to the participation age. People are participating on the internet. Now, why does he say that? If you think about and try to make some correlation, the Ice Age is more like early 50s and 60s or early 70s where there were the huge mainframe servers. Even you might have seen the photos which was required a helicopter to carry the servers. We carry now much bigger, much faster, bigger in not the size but the processing mobiles these days. But that was an Ice Age. The Iron Age was where the before 70s 80s it has started getting more and more about the computers. People started taking more and more about the computers. They started understanding what is computer, how do you use that. The Bill Gates changed the world. He started with the industrial age, and that's what the Windows 95 98 that has changed the world. People have started more and more PC, and everybody started getting more into the computers now. The information age, the late 2000s or rather the late 90s and the early 2000s, that was the area of the information age. People started using more and more internet. We started using the email, we started using that. So the Hotmail was a buzzword, right? That was an information age. People were started searching on the computer. Google, that was the phenomenon that days. And then comes the WhatsApp, then comes the Facebook, which has changed the world tremendously. And iPhones, the smartphones have changed the industry. People started more and more participating over the net because now you have the devices available over your hand very easily. You can collaborate with anyone within a minute or rather I would say seconds of the time. The person living in the furthest part of the world doesn't matter. Your mobile phones or any handheld device would help you to connect with him just with just click of a few buttons. Have you ever thought about what kind of a infrastructure or the backend services goes in behind which makes it possible? Talking over is easy. That's a fine because that's what the easiest thing we are doing. But at the back end, what is running over there? The cloud computing facilitates most of those kind of services. You would try to understand what is that in deeper more and more. This is a Gartner hype cycle, and that's a little older one, the July 2013, where you see the infrastructure as a service. Why I have highlighted here AWS is because Amazon Web Services falls into AWS cycle. But one thing which I have marked on the left hand side, if you see, is a DevOps. If you're thinking of a new career, if you're thinking that, oh, I want to also explore something more in cloud computing, DevOps is going to be the thing for you. Now that's DevOps is little out of the topic for us, but just to give you, DevOps is nothing like it's more like a philosophy. It's nothing, you can't define exactly DevOps. So people say it's a bridge between the development team and the operation team. How do you facilitate the things? That is what DevOps. And I'm sure it would be a very interesting topic for you, and someday we would also talk about the DevOps in some other sessions. But for you, it's very interesting if you can Google out and learn more about DevOps. I'm sure you're going to learn more and more topics about the what is the future going to be around. Let's get back to our future, or rather our present infrastructure as a service model. And if you see in the next part, in the July 2014, it has moved little ahead. It's now in the slope of enlightenment. And I'm sure within a few years, it would be in the part of the plateau of the productivity, where it's a much more matured and a proven model. So that's the what Gartner has to say about the various service models of the cloud computing. And frankly, cloud computing is a reality now. People say they have to move with the time. You have to use the cloud computing. Our dear friend Santa believes, okay, even if I want to deliver millions of people, cloud is the solution for me. Dear friend Reindeer, you are a little slow for me now. But what is cloud computing? Have you ever tried to define that? And here, a friend, Larry Ellison, has made great statement. He says, the interesting thing about the cloud computing is that we have redefined cloud computing to include everything that we already do. I can't think of anything that is not cloud computing. With all of these announcements, the computer industry is the only industry that is more fashion driven than women's fashion. He's right in a way. Why? Because if you go and ask people, sometimes you will find why is the person like Larry Ellison is giving this statement. But when you go and ask people, they would say, oh, move it to the cloud. Oh, store on the cloud. And when you ask them, do you know what is cloud? They say, oh, storing on the internet means cloud. Is that true? If you are doing everything on the internet, is it the cloud? No, that's not the right thing. We need to understand what is real cloud computing, and then only we need to go further. And that's why people who try to define the cloud computing, you would find a different kind of a definition. You would find that somebody is saying something different, somebody is saying a little different statement. That's why it says it's like a big elephant and few blind men. Who is touching its ear would look full like it's a fan, while touching its tail would say it's like a rope. And our first duty or our first task for this today would be, let's try to define what is cloud computing. Let's define the cloud computing. If you try to see the definition by Forrester, they say the cloud computing is a form of standardized IT-based capability such as internet-based services, software or IT infrastructure that is offered by a service provider that is accessible via internet protocols from any computer, is always available and scales automatically to adjust to the demand. Now this might sound a little interesting, but it's not very easy to understand. You would say, what do you define by the form of standardized IT-based capability? How do you define internet-based services? What is exactly point here? And the Forrester says it scales automatically internet protocols. What is that all about? Let's try to define little more. And we go with the definition by the NIST. NIST is a National Institute of Standard and Technology, that is the de facto for the any definition in the technical world. And NIST defines cloud computing is a model for enabling convenient, on-demand network access to a shared pool of configurable computing resources. For example, network, servers, storage, applications and services that can be rapidly provisioned and released with the minimal management efforts or service provider interaction. This cloud model promotes availability and is composed of 5 essential characteristics, 3 service models and 4 deployment models. Now just read it again for a moment. Do you find it very easy to understand? Sometimes it might not be, because you would always have a question, what are those five essential characteristics? What are those service models? What are those deployment models? You would like to understand more and more about that, right? So, if I tell you in a very simple language, any business service. Now, you would like to understand what is a business service. Are you offering some software or are you offering any IT service or IT offering as a service model? This could be email as a service. This could be collaboration as a service. This could be CRM as a service. It could be hardware as a service, compute power as a service, networking as a service. So you are offering something IT offering as a service model that is available on demand, which is accessible over internet protocols. Now, internet protocols, why do I say? Because it might be available over your intranet or internet, which is scalable, elastic by nature, that charges you on a pay as you go model and uses the resources optimally. I just reiterate the words very carefully. Any business service which is accessible over internet protocols, available on demand, elastic or scalable by nature, charges you on a pay as you go model, and uses the resources optimally with the shared pool of resources is known as cloud computing. Now you would think, what are those five things you talk about? These are nothing but the five essential characteristics defined by the NIST. If we try to go a little deeper about that, it's very important we understand those characteristics in depth. Because if you have to take one thing out of this session, that is, or one thing you have to take out of this session is, how do you define cloud computing? Let's understand those five essential characteristics. First characteristic is broad network access or accessible over internet protocols. Something which you can access over internet protocols, which means it is available on intranet or internet. It's not like a client desktop kind of a service, but more important, with your internet protocols you can access it over there, and that's a very important point for that. And that's why, again, cloud is not always internet. Cloud can be intranet too. One business service which offers you rapid elasticity. That means it's a scalable by nature, elastic by nature. Whenever it's required, it can scale up and scale down. It's a measured service. Whatever you are using, you are going to pay only for those services and available on demand. Now, if I give you some examples over there, suppose you want to procure a machine. If your organization wants to procure a server, it's a special server class machine with around 60 GB RAM and around 30 CPUs and kind of a configuration you want that. Now, if you want to procure that kind of a machine, how many days would it take for you? Sometimes it may take 4 hours, sometimes it may take a day, sometimes it may take a week, or even more. Based on the process defined at your organization level, it might require to floating a PO and getting this, finding the right code and everything. It would involve a lot of things. If I tell you, with the cloud, you get that kind of a server in 5 minutes, would you believe me? You have to. And that's the power of the cloud. It's available on demand. Advantage here would be, if you are in your organization and you are procuring your own infrastructure, Once you procured it and you find, no, it's not worthful for me, or it is not the right configuration for me, you still have to keep it with you. That is a capital expense. With cloud, everything is more like an operational expense. So you procure, you pay as much as time you are using it. If you are not using it, you remove that and you don't pay for that. So if you find this is not the right size for me, I need higher or lower size, again that's available for you. And advantage is you remove the size and get the new instance very easily. That's the power of the measured service and pay as you go model. Now, there are cases where the system is going to go down. Why? It might be unpredictable or very high load, or there might be some kind of a DDoS attack. There could be a various reasons, right? And that might bring down the systems. We have also seen the outages in the past, that like the couple of years back, Twitter itself failed because on the Christmas day and the New Year day there were huge number of fishes and that could not handle. Now I don't say that Twitter is not on the cloud. Twitter is on the cloud, but cloud is the service which would help you to give you rapid elasticity. If you want to scale up very easily, you can do that. And if you want to scale down very easily, you can do that too. The scale up and scale down part is very easier for you. And here also you get an advantage of the measured service pay as you model, and with the availability of on demand. Once you scale up, you might be adding more resources. You might be paying for those resources only for the period you are using it. And once you don't need those resources, you can release them, you can scale down, and you would not be paying for those resources. Now, after all this, what is resource pooling? It is more like a optimally using your resources, using it to optimize the services. And if you have not yet about the concept called the multi-tenant, this is the concept here. The multi-tenancy is more about where a resource is shared by the multiple tenants of that. Now, tenant does not mean the user. Generally, a tenant might be the group of the users. If you think there are three separate companies who are working on some softwares, so they come and make a single software, and all the employees of those companies are able to access that. But the advantage here is if company A needs some kind of a customization, like I would need the color combination like AB, something like a red colors, I need some kind of a security features, I need some kind of a pages to be shown, while company B would have a little different kind of a requirement. A one software can serve you with some kind of a business logic implementations. They could serve you that from one data center, it's serving all different companies, and all the users of those companies would be able to access the same software. Here comes the concept of the resource pooling. The companies here are the tenants, and each user or the employee of that company is the end user. So tenant is nothing but the group of the people for whom system is customized. And the resource pooling gives you a better resource optimal usage. Just take an example. Suppose you have a 100 GB RAM machine and 1000 GB or 1 terabyte hard disk. If only one person is using, he is using only 10 GB RAM and 100 GB hard disk. That means your 90% resource are unutilized. They are wasted. Can you do some kind of a virtualizations? Can you add some kind of a techniques here that there would be 10 people using this? Each people would be using here 10 GB RAM and 100 GB hard disk. That would make it a fully utilized resource because now 10 tenants are using this. Each one is getting 10 GB RAM and 100 GB hard disk. That is known as a resource pooling. Resource pooling plays a very important role in the cloud computing because when you are going to offer the various services, it should be optimally utilized. And then you would be getting better advantage of the pay as you go model. So these are the 5 key attributes defined by the NIST for cloud computing. I hope everybody is clear about this. I can also recap one more time. Any business service which is accessible over internet protocols, which is elastic by nature or scalable, which charges you on a pay as you go model, available on demand, and optimally uses the resources, is known as a cloud computing. Do you know any famous examples? Do you want to try for a moment and think what are the famous examples of the cloud computing have you used about? Just think in your mind for a moment. So, what all examples come to your mind? I'm sure most of the people might be thinking of iCloud. But do you know Gmail is a classic example of cloud computing? Now you would think how the Gmail fits here. Here think about a business service is offered to you. What is that business service name? Email as a service. That is available over internet, so broad network access. It's a elastic and scalable. We all know that. So whenever you requirement, it keeps on adding more and more data. So have you ever thought about that you should delete your mails because your Gmail inbox is going to be full? You can keep on adding more and more things. Is it a measured service? Because quite a few of you who are using the standard Gmail would feel that oh it's a free of the cost. So how does it charge? Actually, Google Mail or Gmail has a wonderful offering for small, medium, large enterprises where you can go and procure the email service from them. So for example, I'm having a Intellipaat email address. It might sound like abc@intellipaat.com, but the whole backend might be running on the Google. What Google says is you need to procure your own domain and then make certain configuration changes over there. Once you do those kind of a changes, give it those changes with us, procure the licensing, and for each license it might be costing differently. So for India it might be costing around 1500 or 1600 rupees. In US and other it might be costing around $5 and something like that. So based on that, and $5 is the monthly, so over the period it's a $60 around for the whole year. Based on that, you would think of you can procure as many licensing for your organization you can do with the Gmail. And you can keep on adding more resources. It's available on demand. So today you have a 10 user license. Tomorrow you want to add the 3 more user license. You can easily add that. And it would be charging you on a pay as you go model. So as many licenses you are using, it would be charging you. If you are not using any more license, it would not charge you. And that's why it also gives you rapid elasticity. So if you want to scale up more, you can do very easily. And it also gives you the resource pooling. Why? It's a classic case of you can think of the multi-tenancy setup. Because when you get an email ID, it would say abc@intellipaat.com. Now, it doesn't say that abc@gmail.com. No. At the same time, if you think of there is another organization, like you take all the examples of the popular, the education institute like IITs, just an examples. We don't know where their email servers are hosted, but just an examples. IITs of the Indias. If they are also getting the email services from Gmail, it might be xyz at that iitmumbai.com, xyz at that iitkharagpur.com, something like that would come. So there would be a based on your domain, it would be configured for you. There's a single software serving multiple tenants and the all the users who are having the email IDs, those are the end user of those tenants. I hope now it gives you how this makes a picture for you. What are the various email services and how does it work for you? Think about the huge number of cloud computing offerings. You can think again, come out of the world of the iCloud and you can think of outlook.com. You can also think the YouTube. You can also think Netflix. You can also think, as I said, Gmail, Salesforce, Dropbox, even people say Facebook, and many more. Those are the classic examples. People say they are the cloud computing offerings. On one or another way, they are offering certain services for you. And that's why you would think everybody is offering same. That are the Gmail is offering much different than what Amazon is used to offer. Amazon says I offer you the compute power, storage, everything. Gmail offers me emails. Are they same? That's why based on the offering, based on the service they are offering, there are various kind of a service models. The first one is a software as a service model. Now here the end user could be any person. Like you are using Gmail, you are the end user. You don't care how this is programming, how this is serving your data. No. And if you see it's anybody's game, any child can play with that. That's the exact concept here. It's a software as a service model. And you think of the Salesforce, the Google Docs, Gmail, Office 365, Dropbox, and many more are the classic examples of software as a service model, where a ready to use software is offered to you in a service model, where which might be available over the broad network access, available for the elasticity. You can use with the measured service and paying only for the service you are using. Like for the Dropbox, you would be paying for the storage you are using over there, right? So based on the service you are using, you would be paying for that. Available again on demand. You can scale up, scale down very easily, and uses the resources optimally for you to give you the multi-tenant scenario. So this is about the software as a service model. Now think about the platform as a service model. A platform is offered to you. Now what is a platform here? Suppose you are a developer. Now if you want to host your application on a cloud, what are the steps you are going to perform? First step obviously would be developing your application, then testing something, then you go and host on the cloud. So to host on the cloud, you need to get a some server from there. Then might need to set up for the scalability aspects. You might need to set up for the high availability. You might need to set up for the backup. You might need to get the URLs and then configure that it would be accessible over internet with the easier way. So it requires a lot of tasks other than the programming. If there is a platform available for you, which would be taking care of all those activities, and only your focus area would be you just work on your development, your core aspect. That's a platform as a service solutions. So in a platform as a service solutions, an infrastructure, rather a managed service platform is given to you, which would take care of the giving you the hosting of your services, scalability, backup, disaster recovery. All those aspects would be taken care by the platform itself. And the classic examples are Amazon itself provides with the Amazon Elastic Beanstalk. Microsoft Azure and Google App Engine started with this offering with the platform as a service model only. But then after the success of Amazon, they started moving more into infrastructure as a service model. But in a platform as a service model is a platform where a developer needs to focus only his core strength about the development. The platform would take care of the deployment, scaling, backup, and other aspects of this your hosting services. Moving to the infrastructure as a service model, this would be core focus for us also, because Amazon is the king here. Amazon offers the various services with under the AWS. So it offers a view virtual compute, virtual storage, networking kind of a service which you can use. So it might not be available physically to you, but virtually hosted on somewhere the data center of the Amazons and Microsoft of the world. You can access those services, the compute, storage, network or desktop services, use it, and then whatever you want to achieve with that. If you want to use those services for hosting, for some storing some backup, for disaster recovery, you can do that. And again it follows all the 5 principles defined above of the by the NIST, the cloud computing attributes, and that's why it's an infrastructure as a service model. Now, as Mr. Larry Ellison said, it's a fashion driven industry. People loves the buzzword, and that's why there were the various kind of a service model started coming into the picture. People would start telling that okay, there is a business as a service, management as a service, the desktop as a service, network as a service. and various kind of a service model started coming up. And so the new buzzword come in the market is XAAS. That's anything as a service. But NIST recognize only three models: software as a service, platform as a service, and infrastructure as a service. It believes that all other models might fall into one of these only. But as we know, this is a fashion driven industry and people would like to come out with the new buzzwords. So in case if you hear the new buzzwords, you should not think, oh, this is not defined by the NIST. But yeah, that's the truth. It might be falling in one or another way only. Then you also need to understand where is your cloud hosted. And based on that, your deployment model would different. If your cloud is hosted and accessible over internet, anybody can access that. I can access from my mobile phones, I can access from the any of the tablet devices I have, from my desktop, laptop, anywhere in the world with the internet I can access that. That's a public cloud. Public clouds are generally multi-tenant. You would be able to access from anywhere in the world very easily. And all the Amazons and Microsoft and Googles of the world are the classic example of the public cloud. But in some cases, the public cloud you may not like. The reason would be people say something which is on internet is always prone to some kind of a DDoS attack. People may try to hack the things. People may try to make a attack over that. And if some people succeed, how would it work? You want to set up a private kind of a setup where your data is within you. Nobody else can access that. And that's why the private cloud comes in a picture. Private cloud is a quite a few cases more about a single tenant thing where it's for a particular organization. An organization who wants to achieve better security, they would be setting up their own private cloud. It's a single tenant thing. So within your organization, you would be able to access over the intranet, and you would be, or even if you are accessing over internet, it might be through some VPN and other tokens or secure channel you would be accessing after coming to the organization network only. So it's also possible. Yeah, private cloud would pose a few challenges for you, which we would see in the coming slides. How would you do the chargeback, and how would you be doing the measured service and all that part. But it is important. Sometimes when the case comes for the security, when the data security is very important for you, you might need to go for the private cloud. The private cloud would also have another challenge would be it would not be able to scale up beyond certain limits because it's for your organization, right? So you might have procured a certain amount of a hardware or firmware which can scale up to certain level. Compare with the public clouds and they are massively scalable beyond our imaginations. And when we learn about more about AWS, I would tell you how the AWS is providing the scaling services. It would tell you how you can scale beyond certain things. It has that kind of infrastructure which allows you to scale more and more as much as you want. So you want the scalability of the public cloud. You want the security of the private cloud. How do you work with that? Let's use the hybrid cloud. Hybrid cloud is the mix of the public and private, which would allow you to use public cloud for the hosting and some services, for private cloud for some kind of a data storing, and they both would be talking to each other over a secure channel. So you could achieve the hybrid cloud offering. Amazon, Microsoft, Google, everybody, even the VMware provides the hybrid cloud offerings. Now, in some cases, suppose I was talking about the three organizations ABC, they want to say that no, let's make our own cloud. We don't want to take any service from the outsiders. We make our own cloud. Now in that case, that cloud would belong to those three companies only. So it's not everybody can access that. So it's not a public cloud. Again, it's not a private because it's not for a particular company. So sometimes like-minded people come together and make their own cloud. So people with the special purpose or the common interest come and form and make their own cloud. That is known as a community cloud. So where in the community of multiple tenants would be involved. Those are the group of the people coming together for the special or the single purpose, and they form their own cloud. So that is how the community cloud. So if I summarize again, as I say, it's very important that the you from this session you take out what is cloud computing and how do you define that. Any business service which follows the 5 attributes defined by NIST is known as a cloud computing. Now you know those 5 attributes very well. The broad network access or accessible over internet, the rapid elasticity or scalability, pay as you go model, on demand availability, and optimally using the resources with the multi tenancy setup. The 5 attributes defined by the NIST, and any business service which is following this is known as cloud computing. I hope this clears your doubts, and now you would be able to understand, or anybody ask you in the future that do you know cloud computing or have you worked with the cloud computing, you can very well go and tell. Or even if somebody is saying I'm moving to the cloud or means I'm storing my things to the cloud, you can always say, is it scalable? Does it use the resources optimally? Is it available on demand? You can always question that. So that's about the what is cloud computing, the different service models and the deployment models of the cloud computing. We are going to see about those service models and deployment models more and more in coming slides. So let's try to define or understand the cloud computing in a different way. So all together, and this seems to be an amazing car, isn't that? Everybody would love to own this. Yes, it's with all bells and whistles, full support and warranty, everything it is having. This is what, like your own dedicated infrastructure, your own data center. Now, if I just try to say that, if you take a car as an example, what is your end goal? You want to go to your office. From your house to office, that is the only simple goal you want to achieve. Forget about anything else. Now, there seems to be an amazing options. Everybody would be, wow, he's using this car, but at the end, it's serving the same purpose. It comes with a huge cost, huge maintenance, right? Everything would be there for you. Now, what is your end goal? You want to reach to your office and come back to home. That is the only thing you want to achieve. Can you achieve with this? You can, definitely. Even you can do carpooling, right? You can do it carpooling with your friends. They would take to your office, they would come back. That serves a purpose. Why do you need ultra luxury car where your end goal is only to reach office and coming back home? This is more like your hosting service where you're hosting somewhere else on a third party provider. When you're hosting on a third party provider, this would be the case. It's more like a carpooling case. So for the carpooling, you might not be owning it, or you might be doing resource sharing with someone else. Again, this would be costing much higher. You might have a monthly payment, some limited supports. Whenever your friend is available, only then you can go. Everything would be the dependent on that. Remember, what is your last goal? You want to reach to your office. Can this take you to your office? It can. It follows the pay as you go model. Whatever you are using, you would be paying only for that. It doesn't cost you anything for the maintenance because it's being managed by the taxi owner. It's available on demand, right? With the availability of these Olas and Ubers of the world, easily available on demand. It is. And elastic. So you want to go 10 people, call 3 taxis. You can very easily. Doing the resource pooling, you can 3 people can go in the same taxis. And what is the ultimate goal? You want to reach to your office. Does it serve your purpose? It does. Pay as you go model without any maintenance, no upgrade cost required, and if you're using today or you're using 20 years after this, the taxi might be changed. right? You don't need to upgrade it. Let the taxi owner manage it. It would be serving your purpose. So that's more like your on-demand hardware and software case, which would be serving your purpose. Now, I hope this rings a bell in your mind that when you try to see a cloud available on demand, elastic by nature, pay as you go model, optimally using the resources, that's the cloud computing for you. And these are some of the famous examples of the cloud computing. So when you think about the utility computing or the infrastructure as a service, that is more like a Amazon Web Services and Go Grid and all that would fall into. While when you go to the platform as a service, you would go for the Google App Engine, Facebook F8 platform, Force.com, and even the Azure, Microsoft Azure would full there, fit there. When you go for the software as a service model, Salesforce and the Gmail and many more over there, it would be the Office Live, the software as a service models, WebEx and live meetings, and so many would be coming over there. So there are so many cases for you, right? Which is offering you the different kind of a services. So various cloud models offering you, and there are this is a simple list. I said there is a huge number of offering across the world. But yes, the race is led by Amazon, Google, and Microsoft. And let's try to understand the cloud delivery models. When you talk about the software as a service model, as we say, it's a famous with the email, CRM, collaborative. Well, for the past, it would be more like a application development, decision support would be cases. For AWS, it would be more like a caching, networking, compute, and all that would be the cases for them. For SaaS, the application would be hosted centrally, easier for you for the when you want to use for the testing something with a single place which would be serving your requirements. Most important, it reduces your IT operational cost. You do not need to install the new softwares or release the patches anything because everything is being managed by the service provider. In compare, when you go to the PaaS, it does give you the facilitation of hosting capabilities, designing for and the developing the applications. It's integrating web services and database. So it's a platform given to you, right? A platform which would be managing your databases, your application, hosting, scalability, streaming. It would be doing that. In compare, when you go to the IaaS would be giving you virtual desktop, virtual compute power, virtual server powers, available over internet, scalable, networking, everything available, persistent storage, storage for the internet, everything would be for you. So each cloud model would have something for you. And that's why it's very important to understand at this point. This is the distribution of control. Now, just from this image, don't try to make that green means very good and red means bad. Here the purpose is different. We are trying to compare 5 different models and what kind of a control you get and what kind of a control you need to release or you don't get over the part. We will start with the dedicated IT. In the dedicated IT, when you think about this is your own organization stuff where your organization owns everything. The organization manage data centers. So they would be having their own storage, they would be having their own servers, they might be creating a virtual machines on top of that and hosting an application on top of those virtual machines, and then that application would be creating a data. When you see the sequence, each server would have some kind of a storage. A virtual machine would be hosted on a server to achieve the more resource pooling and everything. So people can or the end user can access this virtual machines, and virtual machine would be working like a virtual servers, and user would be hosting an application on this virtual server. That application would be generating certain kind of a data. Now when you see all those, everything is within your organization's control. They manage, they do everything. But at the same time, when you think of network would be a shared thing because your organization might not be providing network. They might be taking internet and other service from some third party providers. It could be the Bharti Airtel in India, or Vodafone, or Reliance Jio, or Tata, something like that. So yellow means there would be a two organizations shares control with the service provider. Now what happens here? The service provider is an internet service provider. So it can fail also at the two levels. It can fail at your end, or even it can fail at the service provider level. So yellow means something where you are sharing the control, where you are not the only responsible person, where in the green you own everything, you control everything. Now, I would also like to give you a statement. I'm sure most of you might have seen the movies Spider-Man, and it says, with the great power comes great responsibility. So think of all the green options. You have the great power, you control everything. But that means what? You have to manage everything too. It's your responsibility. So you have to plan for the backup, you have to plan for the high availability, you have to plan for the disaster recovery, you have to plan for the right sizing, you have to plan for the chargeback. Everything you are responsible now. Support, maintenance, infrastructure, the real estate, everything would be your responsibility. So the control, you get everything, but you have to manage that too. From that, you go to the hosting provider. The hosting provider would be where you would be hosting somewhere else in some hosting provider case. When you say hosting provider, that would be some third party or third party who is providing you the hosting services, where the network, storage, server would be in their data center. Yeah, you might have the sometimes the rights based on the service you are taking. So you can say that okay, procure this kind of infrastructure like this 30 GB RAM or 100 GB RAM machines and the 1 terabyte hard disk, something like that. How do you plan the backup? Everything you can have your own say. You can even go and check those things also physically, but everything at the end is in hosting provider infrastructure. So it would have the some control from the hosting provider also. So you are sharing some control here, because if the hosting provider wants, they plug off the things, your server would not be working, your storage would not be there. Correct? Yeah, on this server, whatever the virtual machine is created, only you can access, because you might have done with your own virtualization techniques, you know the keys, so nobody else can access that. And so on inside that virtual machine, whatever the app you are installing, whatever the data you are storing would be completely in your control. So here, from dedicated IT to hosting provider, you started losing the control, but at the same time, you are managing less things here. Why did you go to the hosting provider? Because you have to manage less things. Your responsibility would be decreasing. Your support and all of the aspect would be decreasing. From there, if you go to the public IaaS, public infrastructure as a service provider, how do you plan this? You go to the cloud, Amazon cloud, Microsoft cloud, they would even not say where the data center is. Microsoft says their data center is in Mumbai, not sure where, right? So even you would not have a physical access that you would, once you don't know the address, you would not even have a physical address. So what kind of a server they are using, what is the underlying storage, what is the underlying network, you would have a known about that. And that's why you are not responsible for it. So the service provider here manages that. And at the same time, what you go is you go to the Amazon and say, I need a virtual machine. So Amazon would give you a virtual machine. Once you have that virtual machine would be running on provided by Amazon. So it's a shared part. Amazon would give you a public key or the private key. A public key would be stored in the Amazon for the verifications, and then it would be able to access this VM. So it's a shared part. Yes, Amazon cannot log into your VM, but if something goes wrong at the server side, it would not be working for you also. So here you would have a virtual machine, And on that virtual machine, you would be deploying certain application too. That application would be yours, so you have a full control. You can log into that virtual machine and you can manage that application, and whatever data being generated by that application would be your data only. Amazon or any other AWS provider would have no control over that. So what happened from hosting provider to public AWS? You started losing more and more control. You don't manage at all about the server, storage, network, anything, nothing your botheration. You only focus on app and data. So from AWS to public PaaS, the PaaS works in a little different way. Though it would have a network storage servers, but it doesn't give you virtual machine. It gives you services. Services for deployment, services for the scalability, services for the accessing some of the, like for Google, you want to access the Gmail from that or the Google Talk, something like that. You can do that. And there you would be deploying your application. Now this application would also be using these services. So it's a shared aspect. Now why? Suppose you have made an application and hosted on Google that might be using the Google Doc, that might be using the Google Mail, it might be using the Google Big Data data table, Big Table. So it is making a lots of calls to these services provided by the cloud provider. So we call it a shared entity. But whatever the data is being generated, that would be only known to you. Your structured data, you have configured that. So it would be in your control only. You have to manage that. From PaaS to SaaS you go. SaaS gives you ready to use software. So you don't have any control till the app part. Think about the Gmail only. Do you control the app? No. You just see the data. Now why do you see the data is a shared entity here? Because again, you don't know the data structure, because that's the data structure defined by the cloud provider and they can read your data. The classic examples, if you receive a mail from your friend saying let's go for a vacation, it's a likely that the Google will show you advertise of the yatra.com or the makemytrip.com. They would tell you how using artificial intelligence they are reading your mails. So data is a shared entity here. Try to rethink from the dedicated IT to the public SaaS. You start losing lots of control. Now, as I said, the losing control is not bad because sometimes it's advantageous. If you trust that service provider, you know that it's a proven one, it gives you what you require services. Then, in this case, your lots of headaches about this hosting and everything is being taken care. Your data only in the SaaS is a shared entity, while here only network was a shared entity in dedicated. So you see the transitions, but as I said, with great power comes the great responsibility, and lots of things has eased for you. You don't need to manage, you don't need to plan for the backup, anything for you. I hope this gives you much insight about the distribution of control and how these different service models works for you. Now let's try to understand these public, private and hybrid clouds. The public clouds gives you a mega scale, the high scalability, available publicly, massively scalable, virtually unlimited resources. Private cloud in compare gives you more security. They would be enterprise owned or lease. They would be in a cloud company model, a company's own data centers and providers. While in compare when you go to the hybrid cloud, that composed of the two or more clouds. It's the mixed usage of the both public and private clouds. It would enable your applications and components to be spread between multiple public and private clouds. So hybrid would be mix of that, where you can get the plus of both, or even if not taken care, it might get the negatives of the both too. So when you go for the hybrid, generally what happens in the hybrid, people would be storing their app, web servers in the public cloud. They would be storing their data in the private clouds, and they would be connected with the each other. So public and private would be connected using the secure tunnel, secure channel over there. The VMware's, Amazon VPC, Microsoft Azure does provide the hybrid cloud solutions for you, which would help you to achieve the security as well as scale both in this case. So these are the sample benefits and risk, and again it's not a exhaustive list, it's just a indicating list about what are the advantages. When you go to the public cloud, you get the advantage of the cost. It's much cheaper. much cheaper, because you don't need to pay for the real estate, you don't need to pay for the maintenance, you don't need to pay for the support. Everything is being managed by the cloud provider. You don't need to pay for the upgrade and all that part. Your time to market is much lesser here. It's elastic by nature, so self-service provision very easy to use. But what you lack is you lack the control. Security might be a threat in some cases. You have to plan for the data migration also. How would you migrate data from your organization to public data? How would you do that? How would you take care of the software licensing? If it is a vendor lock-in, how would that work for you? In compare, when you go to the private cloud would give you control, it would give you security, it would give you compliance because you have all the things, everything with your control. But it lacks is a scale. It's a scalable up to certain limit. Beyond that, you need to keep on procuring more infrastructure. It would be costing you also. So you have to think whether do I have a real return on investment ROI over there? How do I charge back my users? Those are the things you need to think of. The how do I achieve the pay as you go model in the private cloud? In compare, when you go to the hybrid cloud would give you the flexibility, it would give you the security, it would give you the efficiencies. At the same time, it would have advantage of the both public and private. It would same time it would have a limitations of the both. It can have a multiple points of failures. So it will have the same risk as public and private if not taken care well. So public, private and hybrid are very great to use based on your use case and what are the advantage you want to achieve. You would be able to use one of them. And that's why let's try to understand certain key characteristics offered by the cloud computing. Cloud is agile. It comes in a various models, various sizes. It's a much flexible model. Scale up, scale down, on demand. What you want to do, it's available there. It's a cheaper, cost effective, very cost effective. Pay as you go model. Device and location independence, access from anywhere in the world, and this multi-tenancy gives you real centralization, peak load capacity, utilization efficiency would be very helpful for you to optimally using the resources for saving the cost and giving more advantage to the end users. It's reliable. People would believe, might not believe, but it's a much reliable. Now people have, if I tell you the example of Amazon, the Nasdaq has moved there, the NASA is moving there. The people are going to this. They trust that it's much more reliable for them. It's very scalable also, available on demand and scalable for you. So highly available, highly scalable, and believe me, it's a sustainable model. It's a highly sustainable model. The cloud computing is going to be here over the years and going to conquer the world completely in few years. Yeah, virtualize gives you much more advantage. Virtualize would give you advantage that it's a you get more optimal resource utilization. You would be able to achieve better cost savings and everything would be there for you. So these are some key characteristics of the cloud computing, which I'm sure you would love to learn more. When you progress more about that and when we start learning more and more about Amazon, this would be more useful to understand and go deeper. At the same time, this is a survey done by the RightScale. RightScale is one of the cloud brokers who provide the various kind of a cloud services. Again, it uses the underlying cloud would be Amazon or Microsoft of the worlds, but it gives you brokerage a middleware kind of a service. And it has done some surveys and it says that people go to the cloud because they get more scalability, they get better infrastructure access, high availability, faster time to market. So these are the plus for the people and that's the reason they go to the cloud computing. And that's why this is just a simple use case for the cloud computing. Again, this is not an exhaustive list. It's just an indicative list. Cloud computing would be useful for you when you want to use it for the infrastructure as a service. So you want to transform your infrastructure to the cloud. You want to use for the SaaS part. So where you would be moving your SaaS to the cloud. So software as a service, your email and something you want to host on cloud. It's a perfect case. For your hosting services, dev and test is the best solution because suppose you have a huge infrastructure, large infrastructure to work with, and in that case, infrastructure you are using If you want to do or simulate some kind of a testing environment for that, are you going to procure the similar environment, which would be costing you a lot? But if you're on a cloud, procure for only 3 hours, pay for only 3 hours, and you can do that kind of a testing. Dev and test, POCs are the perfect examples for that. People are using lots and lots more for the backup sites, for the disaster recovery, for high performance computing. It's said that even in Amazon with right kind of a HPC you are using, you could make something like a kind of a supercomputer, not exactly supercomputer, very easily there too. So these are the use case for the cloud computing, and people would be using it for one or other reasons for the cloud. Now people would be saying, should I use the cloud? If I have some kind of a programming language, I know Java, .NET, PHP, Ruby, Python, C, C++, Swift or Android, or I am having some IS skills like I know I'm a Windows administrator or I'm a network administrator, I'm a DB, I know the container services. Is the cloud right for you? I tell you, cloud has everything for you. What you want to use, the cloud is having that. You can use that. There would be something for you. You are a Java programmer, there is a pass for you. You can create your own SaaS. If you're in IT services, you can use the make your own private cloud, or even you can use the public cloud like Amazon something for hosting and all the services. So there is something for everyone in the cloud. And once the cloud has started, the people have started the cloud open source movement too. Open cloud is more like a open formats and open interfaces. There is no vendor lock-in here. It's available for the interoperability and portability. It's not only open source, but it is having the open formats too, open interfaces too also. So that's why cloud with the open source is getting more and more advantages. People have started moving there into cloud. There is a case like a OpenShift, and then Red Hat has some more offerings, and the people are coming different cases to use the cloud in a open source world. But is cloud all good and good about? Are there any challenges? There are. People are worried about the data. People are worried about the security. The cloud computing does have the worries part too. One of the biggest concerns people are having, the loss of the control. We saw that. Is the loss of control good or bad? That you need to decide. If you are with the right cloud provider, it might be good. If you are not with the right cloud provider, it might be a worrying for you also. How do you integrate my federated services? Is it possible? Is it an interoperable? If I want to move from one cloud to another cloud, is it an easier way? No, it is not at all. How do I achieve the accessibility and UI limitation of the web application? The web application, if I'm hosting on a cloud, would the whatever the service offered by cloud, if there is some web and UI limitation, would it work for me or not? Is it really reliable? Does it give me the required performance? Can I access offline? If it is having a vendor lock-in, if it's not interoperable, how would I do? And if it's what about the hidden cost? If it's going to charge me something which is unknown to me, is it going to drive my business values or not? What if cloud itself is down? There are business surprises. There are people who are going to use the cloud for the notorious reasons, and that's why there could be a consequence of the creative destructions. How about the policy and compliance? Is it compliant to Euro policies, HIPAA compliance, and what all the other compliance? Does it follow that or not? Does cloud work on the forensics and the mitigation for that? So these are the definitely concerns various organizations would have, and I don't deny that. Yes, the most popular clouds like again the Amazon and Microsoft and Googles of the world are taking care of that. But you need to understand whether it is meeting your concern or not, or rectifying your concern or not. And that's why the cloud security is major challenge for the cloud beginners. People who are in the cloud since years and they know, no, now cloud is much stable, it's much secure, and I should be not worried about the cloud a lot. There are certain security issues also in the cloud, and that's why there is a very nice article available by Cloud Security Alliance that is known as a Notorious 9. The link is given at the bottom. The Notorious 9 list 9 Major security issues or threats for the cloud computing. They say data breach is one of the major threats. There could be a problem of the data loss. How about account hijacking? If you are using some cloud which does not have the secure APIs, what about the denial of services? What about the malicious insiders? If there is an abuse of cloud service, people misuse that. If there is an insufficient due diligence and shared resources, shared technology issues, and they were explained that extremely well way, and what are the mitigations also for that in the PDF mentioned here. I would recommend if you get time, just read about the security issues or the Notorious 9 from the Cloud Security Alliance. Now, Cloud Security Alliance is an alliance formed by the top software companies that includes the Microsoft and Googles and Facebooks and the Amazons of the world, where they have made an alliance for the cloud that's known as the Cloud Security Alliance or CSA, which works on the improving the security of the cloud computing. So when you want to come up with the cloud is a cheaper, it's a scalable. It comes with a very small startup cost. It's available on demand. So it's all about the OPEX, no CAPEX. It's a highly scalable, elastic. But at the same time, people worry, what if cloud is down? People think cloud is not yet mature. What if there is a lock-in for the cloud? Vendor lock-in. It's not interoperable. And how about the security? So over the period of time, the cloud has matured much more than what it used to be in 2018 to what it used to be now in 2016. And I'm sure by the in couple of years, it would be much more mature to use the cloud computing. So this is all about the cloud computing till now we studied. So till now we studied what is cloud computing and what is the definition of it. How do you define the cloud computing? And as I said, this is the one take point. And I'm sure now you would remember that any business service which follows the 5 attributes defined by NIST is known as cloud computing. There are 3 service models, 4 delivery models. So we'll learn all about the cloud computing, and I'm sure you all enjoyed this. So with this, we are ending the session. I hope you all enjoyed that. Have a great time. Thank you and bye bye.